Good morning. So today we will learn about the mathematical formulation of second law of motion, which is very important to the examination point of view. Okay. Okay. Let us imagine that this is a ball which is suppose at a rest. Okay. And this ball has mass of m. Since it is at rest, we have taken that the initial velocity of this ball is u. Okay, we have just imagined it. Clear that the ball is at rest, so the initial velocity will be 0. Now suppose this ball have to move from this position to this position, then automatically the ball will not move. We should apply some force. Okay, I am applying the force to this ball, then this ball will have some acceleration. Okay, then after some time this ball will reach to a certain position. Okay, and while moving this ball, it has attained some velocity. Suppose at this position the velocity of this ball, let it be v. Okay, let it be v, or we can take it as a final velocity, it as a v. So we have already discussed that initial velocity is taken as u and final velocity is taken as v. Okay, so I have already written that if a body of mass m, okay, this is a body of mass m moving at initial velocity, it was earlier we have imagined that this is at rest, so at initial velocity u and uniform acceleration, when we have applied the force here, this ball is moving, okay, with an uniform acceleration. Clear? Then from this position to this position, when the ball was moving, then it has attained some time, let it be time t. Clear? So when it has reached here, then the final velocity is v. Clear? Now the initial momentum at this position, the initial momentum we represented it as p. So we know the momentum formula, m into v, or mass into velocity. Here see, mass into velocity. So this u is called was initial velocity. So initial momentum will be m into u. Similarly, final momentum will be m into v. Is it clear? So initial momentum I have represented it as a p1. So it will be mu, and final velocity it will be p2 equal to mv. Clear? Now change in momentum. So from this position to this position, what is the change? Means we have to do subtraction. This one minus this one means the final momentum minus initial momentum. You see, change in momentum. This p2 means final momentum minus p1 initial momentum. Clear? Change in momentum, p2 minus p1. So p2 means mv and p1 means mu. Clear? From here I have taken m as common, so v minus u. Clear? So according to second law of motion, force means F is directly proportional to change in momentum by time. Is it clear? Now the main thing comes, that force directly proportional to change in momentum by time. So change in momentum by time, so it is directly proportional. P2 means mv minus mu, clear, divided by time. Similarly, we have taken common v minus u divided by time. So this portion, you can see this portion is the formula for a, clear. So in place of v minus u divided by t I have taken it as a. So this is the formula for acceleration. So in place of v minus u by t, I have taken it as a. So force is directly proportional to mass into acceleration, clear. So see, if we remove the proportionality symbol, we will write here k as a constant, whose value is always 1, clear. The quantity k is constant proportional to where k is equal to 1. So if this is 1, then it become F equal to ma. So this is called what? Second law of motion, Newton's second law of motion. Next, what is 1 unit of force? Clear? 1 unit of force, it is defined as the amount that produces an acceleration of mass, produces an acceleration of 1 meter per second square of an object of 1 kg mass, clear. Means suppose this is my pen, if I am applying here force, then it will be attaining an acceleration. Suppose it has attained an acceleration of 1 meter per second square, and suppose this pen has 1 kg mass, then if this is 1 kg mass and if it has attained an acceleration of 1 meter per second square, then I am applying 1 unit of force, clear. See, 1 unit of force equal to 1 kg into 1 meter per second square. This is a unit of acceleration, this is a unit of mass. So 1 unit of force is also known as Newton, means the SI unit of force is Newton, clear. So 1 Newton equal to 1 kg meter per second square. So it is very important for the examination point of view.